Hi, welcome back. In this video, we're going to use the Fundamental Theorem of Calculus Part 1 to differentiate a function that's defined as a definite integral. So the theorem says if you have a function defined as the definite integral from some number a up to the variable x of f of t dt, where x represents any number between a and some other number b, then the derivative, g prime of x, is just going to be f of x. So it looks like all you have to do is take away the integral sign and replace all the t's with x's. Let's see how that works. Suppose g of x is defined to be the definite integral from 0 to x of t cubed times sine t dt. Now, the function f of t is t cubed times sine t. So the fundamental theorem, part 1, says g prime of x is just going to be x to the third times sine of x. And that's it. So the important part is to recognize when you can use the fundamental theorem of calculus. You have to have a definite integral with a number as the lower limit of integration and a variable as the upper limit. If you don't have it in quite the right form, you might be able to do a couple things to get it into the right form before you can apply the theorem. And so let's look at a couple more examples. So in this example, we want to differentiate with respect to x the definite integral from 1 to x to the fourth of secant of t dt. Now notice we do have a number in the lower limit of integration, but we don't have a variable in the upper limit. We actually have a function, x to the fourth. So we're going to have to use the chain rule. And so just to remind you what the chain rule says, the chain rule says if you have a composite function y equals f of g of x, then y prime is going to be the derivative of the outside function evaluated at the inside times the derivative of the inside function. So when we look at our definite integral, the definite integral from 1 up to x to the fourth, that's actually a function of x to the fourth. So instead of 1 to x, it's not a function of x, it's a function of x. So g of x is the inside function, and it's x to the fourth. All right, so we're going to use the fundamental theorem of calculus to differentiate the outside function, and then we'll use the chain rule, apply the chain rule, and multiply it by the derivative of the inside function. So we're going to differentiate the definite integral from 1 to g of x of secant t dt, and that's going to be the secant of g of x. That's the derivative of the outside, and that's the fundamental theorem of calculus, times g prime of x, the derivative of the inside. And so let's rewrite it. So g of x is x to the fourth, and g prime of x is 4x to the third. All right. Let's do something slightly more complicated. So let's look at this one. H of x is defined to be the definite integral from negative e to the x to sine of x of the square root of 2t squared plus 1 dt. So here we don't have a number in the lower limit of integration. We have two functions. Both limits of integration are functions. And remember, the fundamental theorem of calculus only applies to definite integrals that have a number in the lower limit and a variable in the upper limit. So we have functions in both limits. Well, we know we can use the chain rule with the fundamental theorem of calculus if we have a function in the upper limit and a number in the lower limit. But what are we going to do about this function in the lower limit? Well, we can use our properties of definite integrals, and we can break it up. So we can rewrite it as the definite integral from negative e to the x up to some number 0 of the function square root of 2t squared plus 1 dt, plus the definite integral from 0 up to sine of x of the square root of 2t squared plus 1 dt. So we've just broken up the integral, or the interval of integration. So now the second integral is in the right form. We know we can use the fundamental theorem plus the chain rule on that one. But the first one isn't quite ready. So we can use another property of definite integrals, and we can swap the limits of integration. We can go in the reverse order as long as we change the sign. So we're going to rewrite it as negative definite integral from 0 to negative e to the x of square root of 2t squared plus 1 dt. And then the other integral, we'll just leave it alone and rewrite it. And now we're ready to use the fundamental theorem of calculus plus the chain rule on both of them. So this is our h of x. And so h prime of x is going to be negative square root of 2 times negative e to the x squared plus 1 times the derivative of negative e to the x, which is just negative e to the x, plus the square root of 2 times sine of x squared plus 1 times the derivative of the sine of x, which is cosine of x. And that's our derivative. In the next video, we'll learn the fundamental theorem of calculus part 2 and learn how to use that to evaluate definite integrals without having to take a limit. All right, I'll see you in that one.